Okay, let's begin with question number 5 on this paper. All right. The question to white markers. There we go. Okay, let's read and see, and we shall continue. So the producer of a play requires a total cast of 5, of which 3 are actors and 2 are actresses. So he auditions 5 actors and 4 actresses for the cast. Find the total number of ways in which the cast can be obtained. Okay, so we must understand the total required is 5. Okay, total, and then they are men and women. So let me just put man and woman like that. So he wants total required. So I put like this, huh? So total required is there were 3 men, which are actors, actresses are women, so plus 2. So from each of these branch, this is from a pool of. So the pool means like the available from the pool of, you can say like that in English. So there are 5 actors. I'm getting this word auditions. Means from the audition is like a pool of audition. There are 5 actors here and 4 actresses. So this part is 4 out of 4. So 2 out of 4 and this one 3 out of 5. So how can we do a combination of that? So the number of ways to choose. So this is where the counting argument comes in. The counting part. So out of 5, you're going to choose 3 men. Order is not important, so we use the 5C3 formula. Okay, and then multiplied by, combined with, and out of 4 women, we choose 2. So calculating this, we'll get the answer. So you can put either in the calculator straight away, or if you're doing it manually, this is simple. So I'll show you. I'll do 5 minus 3, 2 factorial, 3 factorial like that. 4 factorial, 4 minus 2, 2 and 2 factorial like that. So this is easy to see. There is 5 times 4 times 3 factorial like that. This is 2 times 3 factorial. This part is just do like 4 times 3 to 1 or 3 factorial. This is 2 times 2 because 2 times 2 is 4, like that. Then we do a bit of cut and everything becomes simpler. Ta-da! So 4 is then cut again. So 5 times 4 and then over 2, 10, 20 over 2 is 10. 10 times 3 times 2 is 6. And the answer is 60 for the first part. So for the second part, ta-da, okay, the B part, find how many different odd 4-digit numbers less than 4,000 can be made from the digits 1 to 7 if no digit may be repeated. Okay, there's no repetition. Okay, there's an important part. Sometimes they'll put this phrase, so you'll know that this is the equivalent phrase. So how many different 4-digit odd numbers? Let's think about it. So that means the thing is the word odd and this thing. So the trick in this kind of counting argument, the first thing we must observe is that when given the 1, 2, 3, 4, 4-digit number, so the 4-digit number is the structure. That's why you put the 4 boxes. We must consider like this. Must see whether there's any overlap with the conditions. So they want an odd number. Odd means this part, the last digit, can only be 1, 3, 5, or 7 in this case. So there are 4 choices. So the problem is, and then there's another condition here, which is stated as numbers less than 4,000. So when they say numbers less than 4,000, that means the front digit is limited. It can only be 1, 2, or 3. And 2 of the numbers 3 and 1 are odd. So that is why we need to split cases based on the overlap. Okay, so we split cases based on overlap. Because when the overlap happens, the case is different. Okay, of course, we can group the case 1 and 3 together, but actually splitting it also can, or grouping it together also can. So I'll split it accordingly, meaning that in this case, let's say 1, 2, 3, 4 like that, or this is the first case. Okay, then the second case is here like that. So then 1, 2, 3, 4, or the third case looks like this. So there are 3 cases based on this 1, 2, 3, 4. So this will be either the first digit would be 1 according to 1, 2, or 3, in other words. But actually, the reason is because these two are odd. That's why I'm doing a case like that, and 2. So easy to count like this. So we already placed the numbers. So here got how many choices. So in this box, there could be either 1 is placed there means odd numbers. So 3, 5, or 7. 3 choices. Okay, either 3, 5, or 7. So I put in the box also likewise like that on the second one. Also, if you think about it, there are also 3 choices on this one. Oh, how do I get 3 choices? 1, 5, or 7 as well. Oh, so 3 choices, 1, 5, or 7. Okay, and then, I'll do the other case in a while, the down one. So we're going to do some counting arguments. Maybe I should do that first, so it's in order. Okay, so for this one, it will be, everything can see. 4 choices. 1, 3, 5, or 7. Okay, yeah. Yep, some of these things are considered a bit difficult, but that's why the trick is what is to split the cases based on the what do you say, the overlap. The overlap is happening on the front and back, so we have to take the cases based on that. So let's think and see. Just one, let me think and see. Okay, so the remaining boxes, that means there's 2 intermediate boxes, would be having the case of, let me think and see. 1 is chosen here, so there's 3 choices. So we start from the back, the one that box is 3 choices. This one, it's got 3 choices, it's got 4 choices. So times by the multiplication principle within it, full understanding of it would be done. So 1 number taken, 2 numbers taken, 1 is already placed here, and 1 more digit used here. So from the remaining total, got 7 digits available. So please remember that from here, I put a box around it. On the left there, you can see the 7 digits. So 7 minus 2, just 2 taken. So 7 minus 2, front and back 1 taken. So 5. When this one has 5 choices, and then from here we can do any of the 4 choices. Likewise here, 5 and 4. So this part they share equally, 5 and 4 like that. Okay. So how about this case? Also the same case. Also here also got, after they got 5 choices, it's got 4 because 2 digits are used. Choices are just scribble like that. So 5 times 4. Let's calculate each of these individual, what do you say? The choices. So 3 times 5 times 4 will be 60. This is 60 again. What is 4 times 5 times 4? 80. So the grand total of number of numbers. So this is the total. We just need to add this up. So 60 plus 60 plus 80. And the answer should be, correct, 200. Okay, so this is how we do such a question. Thank you.